Suppose you want to deposit money into an account where deposits increase every period after the first by some fixed number G. For example, at the end of the first year, you deposit R dollars. At the end of the second year, you deposit R dollars plus G. At the end of the third year, the previous year's deposit again increases by G, and so on. It is clear that as these deposits accumulate and earn compound interest, the total value of the annuity grows over time. To calculate the present value of such an annuity, we use the following formula. In actuarial sciences, this is denoted as IS n angle I is equal to the formula you see to the right of the equal sign, where I represents the interest per period, n represents the total number of periods, R represents the initial amount you deposit, and G represents the increase after that first period. PV represents the present value of annuity, and we've worked with this formula before, it's shown underneath, except that when we use it, we must subtract 1 from the total number of periods, hence the n take away 1. If you're curious as to how this formula is derived, drop a comment in the comment section and I'll create a separate video on its derivation. Let's take a look at a scenario where we would need this formula. The question reads, Mark wishes to build his wealth by investing money into an account that offers 4.5% annual interest. For the next 5 years, starting 1 year from today, he plans to deposit $2,000 and with each subsequent year increasing his deposits by $500 more than the year before. For example, after year 1, he deposits $2,000. After year 2, he deposits $2,500, and so on. By the end of the annuity, how much will Mark have accumulated, assuming the interest remains the same? Let's take a look at what this looks like on a timeline. We'll say that this is today, and that's the end of year 5. And in between, we have the end of year 1, the end of year 2, the end of year 3, and the end of year 4. At the end of year 1, he deposits $2,000, and then that jumps to $2,500, then to $3,000, $3,500, and in that final year, he makes a final deposit of $4,000. Note that the annuity ends at the end of year 5, so these first 4 payments will be accumulating compound interest up until that last payment of $4,000. Now, of course, you can find the accumulated value of all these deposits, including compound interest, using the future value formula. But that would take a little bit more time because you're finding the future value of each of these and then adding them, with the exception of 4,000. Rather than doing that, let's take a look at this formula and apply what we know into it, and that way you can apply this to more difficult problems. So to use this formula, we'll say that IS is equal to 1 plus I. Now the interest here is 4.5%, and converting that into a decimal, that's 0.045. So I is equal to 0.045. And for 1 plus I, if we add 1 to 0.045, we get 1.045. And that's being raised to the power of n, which represents the total number of periods. Now, this annuity ends at the end of year 5, so n must be equal to 5 periods. That is being multiplied to R plus G times PV sub n take away 1. So in brackets, we have R, which is our initial deposit of $2,000, plus G, which is the increase after that very first period of 500. So G is 500 and R is 2,000. And that's being multiplied to the present value of the annuity, where n is n take away 1, so that would equal to 4. We'll be multiplying 500 by 1 take away, again 1.045, raised to the power of negative 4 over the interest of 0.045. And we subtract from that, if you take a look at this part of the equation, R, which is 2,000, plus 500 multiplied to n take away 1. N is 5, take away 1 is 4. Now, interestingly, if you combine these values, 2,000 plus 500 times 4, you actually get the final payment of 4,000. And all of that gets divided by I, which is 0.045. Once you've set up your formula like this, you want to go ahead and substitute this all into your calculator. Now, if you do it correctly, you'll end up with a value of 16,171.53. Or in other words, Marc's wealth will have accumulated to $16,171.53 at the end of the 5th year. If you have any further questions as to how to use this formula or how you can apply it to your own situation, leave me a comment in the comment section below. Thank you so much for watching.